Hi, welcome again. So in this video, I want to show the examples of inverse Laplace by using actually the concept of first shifting theorem. But this one, I want to show one of the method to simplify or to factorize the denominator known as the completing the square method. As we did before this, basically, if we want to inverse Laplace the Laplace transform, we first need to change this form or this Laplace transform into the form that familiar or that comparable with the Laplace transform tables that I will give to you, so that we can easily use the tables, use the form to inverse Laplace the Laplace transform and then solve the differential equation. Okay, so before we go to solve this equation or solve the inverse Laplace given here, I want to show you one of the method known as the completing the square method. So let you refer to these examples. I used the sheet here. So the completing the square method, how to use to complete the square method. Let's say we have x squared plus 6x plus 7 here. We want to simplify, or we want to factor this equation. So by using the completed square method, first we write down x squared plus 6x plus something here, and then plus 7 minus something here. So when you put the plus something here, now you minus back, basically you still have the similar equation or similar form of this one. Okay, that's the idea. Okay, so what is the value that we need to put in the box? It's depend on this one. Okay, so basically here is 6 over 2 squared, and also similar here, also we put 6 over 2 squared, so that the plus here and then the minus here, so we still have the same value. Okay, so we can write down x squared plus 6x plus 6 over 2 squared plus 7 minus 6 over 2 squared, and then this one basically we can simplify as x plus 6 over 2 squared plus this one. Okay, so only this one. 7 minus 6 over 2 is 3. 3 squared is 9. So we got 7 minus 6 minus 2. We got minus 2 here. So we can say that the factorial of this one is equal to x plus 6 over 2 squared minus 2. So if you expand this one, you can get this equation back. So that's the idea. Okay, so let we move to the problem or the equation that we have, which is that we want to simplify. First we have, you can refer back to the slide. We have f s is equal to 3s minus 15 over s squared, not s squared, 2s squared. 2s squared minus 4s plus 10. So inverse Laplace, which is that inverse Laplace of Fs is equal to the inverse Laplace of, why it is moving, okay, inverse Laplace of 3s minus 15 over 2s squared minus 4s plus 10. And we can make it more easy by simplify this form. So we have 3 over 2 inverse Laplace of 3, okay, s minus 5 over 2. So with that we have s squared minus 2s plus 5. Okay, so we already simplified the this one, and then next step is how to solve or how to the inverse Laplace. But before that, we apply the completing the square method to factorize this one. Okay, let's start here. So we have, is it under color? Maybe you can use the blue one. So s squared minus 2s plus 5. If we look at before this, how to use the completed square method, we write down s squared minus 2s plus whatever here plus 5 minus back something here, and what is the value in the box, which is that depend on this one. So the value in the box should be minus 2 over 2 squared. So minus 2 over 2 squared is minus 1 squared. Okay, so we put that as minus 1 squared first. So we have s squared minus 2s plus minus 1 squared plus 5 minus 1 squared. Okay, like that. So we have s squared minus 2s, this one minus 1 squared is 1 plus 1 plus 5 minus 1. Okay, so this one and this one we can simplify. We can write down as s minus 1 squared, and then this one is 4 or 4 okay, 4 or 2 squared. So this one is similar to this one. So we can again back to our case, which said this one is equal to, okay, we have where is it, 3 over 2 minus inverse Laplace of s minus 5 over s minus 1 squared plus 2 squared. Okay, but because basically this one we already proved that similar to this one. Okay, then we write down 3 over 2 inverse Laplace of 1 We try to play again. Let we put s minus 1 minus 5 plus 1, okay, over s minus 1 squared plus 2 squared. Because in the table, or in the table of Laplace transform, we have some sort of like this, S1 and S1 regarding the first shifting theorem, which is the S minus A, if you remember. Okay, so that's why we try to rearrange this one so that become in this form, so we can compare to the first shifting theorem theory to use the Laplace transform. Okay, so if you minus 1 here, plus 1 here, so this all is still similar to this one. Okay, so from here you got 3 over 2 inverse Laplace of 1 is equal to s minus 1 minus we put plus minus 5 minus 4 over s minus 1 squared minus 2 squared here, and then we can have 3 over 2 inverse Laplace of s minus 1 over s minus 1 squared minus 2 squared minus 4 over s minus 1 squared minus 2 squared. And by using the linearity concept, actually we can solve one by one. So we have 3 over 2 inverse Laplace of s minus 1 over s minus 1 squared minus 2 squared minus inverse Laplace of 4 over s minus 1 squared minus 2 squared.
Plus 62, H1.
Okay, so we have two term here that we can solve separately. How to change to another pages? Okay. Okay, so maybe I can write down in this new pages, because I don't know how to solve this one. So again, we have 3 over 2 inverse Laplace of s minus 1 over s minus 1 squared plus 2 squared minus inverse Laplace of 4 over s minus 1 s minus 1 squared plus 2 squared. Okay, so you can refer to the slide. This one we inverse Laplace this one. We will have 3 over 2 e t cos 2t. This one, how to spread? Okay, okay, so inverse Laplace this one, become this one, and minus, we have still this one, inverse Laplace of 1, 4 over s minus 1 squared plus 2 squared. Basically in the table we have solution for sine sine 80 inverse Laplace will become a over s squared plus a squared, like that. So we need to have similar this one to this one. So how we can do it similar? So here we have the color is black. 2 times 2, so 2 we can bring here. Inverse Laplace of 2 over s minus 1 squared plus 2 squared. So this one will become sine 2t, and this one is 2 here, so 2 sine 2t, and then we add this one 3 over 2 e to the power of t cos 2t minus this one. Then if you go back to the slide, it's better. So here, okay, so we got here, then we simplified to be here, and then this is the formula or the rules that we apply inverse Laplace by using force shifting theorem. Okay, so you can try to look at back step by step and try to understand. If you do not have any problem, please do not hesitate to text me in the chat box or contact direct me. So that's all for the inverse Laplace by using the force shifting theorem. Take a break and meet again in next video.